midterm exam 2 topics. You are responsible from the topics of midterm 1, of course. So remember, we have seen units and scales. Okay, you have to know units and scales as soon as you live. Okay, when you die, you can forget. Charge, current, voltage, power. Okay, these basic terms you have to understand. Okay, you have to memorize, understand, remember until you die. Okay, you have to know the behavior of the components, resistors, voltage and current sources. Okay, how do they behave? Okay, what is the voltage current relationship? Behavior of the components means voltage current. Okay, they cannot walk, they cannot run, of course, they cannot speak. The behavior means the voltage current relationship. And of course you have to know the dependent and independent sources. Okay, and then Ohm's law. Actually, Ohm's law is the relationship of voltage and current of resistor. Okay, let me carry the resistor here. Resistor and Ohm's law and resistors. And you have to know what's a circuit and circuit definitions, such as node, branch, loop, ground node, and path, and node voltage, branch voltage, and branch currents. And then we have seen some laws which apply on circuits. KCL, Kirchhoff's current law, KVL, Kirchhoff's voltage law, and related to KCL, we have to know current division rule on parallel resistors. Okay, current division occurs on parallel resistors, and voltage division rule on serial connected resistors. Okay. And then we have seen Very important circuit analysis technique, okay, nodal analysis. Okay, there may be more than one question on nodal analysis. Okay, that's the most important topic on circuit analysis. You can analyze all circuits using nodal analysis. And under nodal analysis topic, we have seen a shortcut method that's called supernodes. Okay, sometimes if you want, you may use supernode technique if it's possible. It makes your analysis easy, one step easier. And we have seen another important technique that's called the mesh analysis. Okay, under that topic we have seen super meshes. If you want, you may use. Okay, if you don't know supernode or super mesh, it's not problem. You can solve that analysis. You can analyze that circuit too. Okay, but supernode and super mesh eliminates one equation and one unknown. So instead of solving a set of equations of three unknowns, for example, okay, you will analyze two unknowns and two equations if you use supernode and super mesh. And then we have seen another topic called linearity. Under that topic, we have seen a superposition technique. If there are more than one independent sources, you can make those independent sources on individually. You will add the responses and find the actual results. Okay, if there are two independent sources, you will turn on one source, analyze the circuit, then turn on the other source, analyze the circuit. You will find two results, and summation of two individual results will be the actual results. And under that topic, we have seen Thevenin equivalent circuit. Okay, we can make equivalent circuits for linear combinations. Instead of a large combination, we can use one voltage source and one resistor. Okay, we can make an equivalent circuit with one voltage source and one resistor. Or similarly, instead of using a large circuit, many components, you can make an equivalent circuit using one current source and one resistor in Norton equivalent circuits. Okay, and application of Norton and Thevenin equivalent circuits together is called source transforms. Okay, I have explained. There is an example on the web. You can follow. And I have explained what is the constraint for maximum power transfer. Okay, if you have a circuit and if you have a load, to have the maximum power transfer, the resistances should be equal. Okay, Thevenin resistance of the circuit should be equal to the resistance of the load. If the resistances are equal, maximum power is transferred to the load. And I have said there is a conversion called delta Y conversion in resistors. But if I ask this question, I will give the equations. Okay, you don't have to remember the equations for delta Y conversion. And the last topic is op amps. We have seen. characteristics of op-amps and some op-amp circuits, such as inverting op-amp circuits, non-inverting op-amp circuits, and buffer op-amp circuits. Okay. And at the beginning, actually, I have explained the comparator op-amp circuit. Comparators with operational amplifiers. Okay. We have seen these topics so far. Okay. So in midterm 2, expect some questions from these topics. Okay. Yes, some numerical examples, units and scales. Question. 10 kilo ohm, okay, 10 volts applied. What is the current I? The current I, we know that the current is voltage divided by resistance. We know that voltage is in volts, okay, 10 volts. And resistance is in ohms, but it's given in kilo ohms in the question. So 10 kilo ohms, okay, if you say this is equal to 1 amp, okay, you lose some points. Why? Because this is volts. You have to say V divided by R, 10 volts divided by 10 kilo, which is, okay, 10,000 ohms, which is equal to 1 milliamps, or you can say 0.001 amps, which is equal to 1 milliamp. Okay, so the scales and units are very important. If you write, for example, the current is 1 millivolt, you lose some points. If you write 1 milliwatts, you lose your points. Okay, the units are very important and scales are very important. If you forget the kilo, you will find 1 amp. Okay, 1 amp divided by 1 milliamp. So your result will be 1,000 times different from the actual answer. Okay, so that's very important. Okay, if you forget kilo times different results. And then another important topic is charge, current, voltage. What's charge? Interaction property of subatomic particles. Okay. Electrons and protons. Neutrons have no charge. And the unit is coulomb. Okay, 1 coulomb, 10 coulomb. And if you move these charts, what happens if charts move? Answer: current. Okay, the answer is current. So current is the motion of charges. If you move, okay, if you move 1 coulomb of charge in move in 1 second, okay, the current is shown with capital or small I, total charge divided by time. Okay, average current is total current, total charge divided by total time. 1 coulomb charge in 1 second is called 1 ampere current. Okay, that's very important units. Coulomb per second. Okay, how to move charge? Okay, if you move charge, it's current, but how to move? Okay, will you push with your hands? No, you need voltage. Okay, voltage is the potential difference between 2 points. It's because of charge density. So you need voltage, potential difference between points. Okay, that's a kind of potential energy. Okay, potential energy. You can produce voltage via different techniques. So if you have 2 points A, B, and if you have 1 coulomb charge, okay, 1 coulomb charge here, and if assume that you need 1 joule of energy to move that charge from point A and to point B. Okay, if you need that energy, then VBA is called 1 volt. 1 volt means 1 joule per coulomb. Okay, you need that much of energy to move 1 coulomb charge. Okay. Voltage sources, they are like big dams. Okay, the symbol is like that or like that. Okay, how do they behave? This is the current, this is the voltage. If you connect some components, there may be some current on the components. Okay, assume that you connect some components, you connect some circuit to the voltage source. Let me connect. This is a circuit. Okay, I don't know what's inside, or let me define the current downwards. Okay, it has a voltage, it has a current. Whatever you connect, okay, you don't know, I don't know, but I know this. Voltage is always fixed. Okay. Voltage is always fixed. So current is changing, as you see. Okay, it takes different values. Okay, from here to here, it takes lots of values for current. It can be 0, but voltage is always fixed, a constant value. Similarly, current source, the symbol of the current source is a circle including an arrow. Assume a current source connected to a circuit. Okay, I don't know what's inside that circuit, but I always know the voltage current relationship is like that. Current is always fixed at a value. Voltage changes. It can be negative, it can be positive, it can be zero. Okay. So for example, question: assume that this is 3 amps. If you use 1 ohm resistor, okay, what's the current of the resistor? 3. Okay. If you use 1 kilo ohm resistor, again it's 3. Okay, because current source, you can change something, but the current of the source will not change. Okay, another topic is dependent sources. Dependent sources. What do they do? Independent sources, for example, 10 volts or 5 amp. Okay, these are independent. Okay, they always supply fixed voltage or fixed currents. But dependent sources, for example, 3ix. Ix is the current of another component. Okay, this is R Ix, or it can be current. This is current dependent voltage source. It can be a current dependent, let me say current controlled voltage source. This example, it can be voltage controlled voltage source. Okay, if you say, for example, this is another R, R1, R2. Vy, you can say 3 Vy. That's called voltage controlled voltage source. Or it can be current controlled current source, voltage controlled current source. Okay, if you draw an arrow inside, 3 Vy. Okay, this is a voltage controlled current source. How can you analyze the circuits containing dependent sources? You will use the same techniques: KVL, KCL, node methods, mesh methods. Okay, nothing changes. Let's analyze a circuit containing a dependent source. One dependent and one independent source. 12 volts, 10 ohms, 5 ohms, 2 Ix. Ix is the current of this resistor. Okay. Let's find Ix. Question. Ix, value of the Ix, what? Let's analyze together. Select a ground. So voltage of this point is 0. What's the voltage? What's the voltage of this point? 12 volts. This is a voltage source. What's the voltage of this point? 2Ix. Let me write with red, 2Ix. So Ix is the current of a component. That component is a resistor. So what is the current of a resistor? Voltage divided by resistance. Voltage of a component is positive side node voltage minus negative side node voltage divided by the resistance. Positive side is the side which the current comes from. So what's the positive side node voltage? 12 minus negative side node voltage 2Ix divided by What? 10. What's that? This is Ix. Okay, so 12 minus 2Ix is 10Ix. So 12 is 12Ix. Ix is 1 amp. This is ohm, this is volts. That's important, units and scales. Ohm's law and resistors. Okay, Ohm's law gives the relation between the voltage and current of resistor. That's it. Okay, it's called as in Turkish vır. Okay, it says, what does it say? There is a fixed ratio between the voltage and current of a resistor. That's it. Okay. Ix, this is R, and this is R. Let me say Vx. Okay. If Vx is minus 15 volts, R is 15 kilo ohms. What's Ix? It's Vx divided by R. Okay. Minus 1 milliamp. If you write amp, okay, if you write amp, that will be wrong. If you write 1 milliamp, that will be wrong. You have to write minus 1 milliamp. Yes. 1 kilo ohm means 1000 ohms. Okay. Now let's combine some components. Okay. If you combine some electric components, okay, it will be CKT, circuits. Okay, let's draw a circuit. Volts, 5 ohms, 2 ohms, 3 ohms. If you write 3 amps, okay, it will be wrong. Yes. And 5 amps. If you see something like that, look. Is it correct? No. Yes, it's correct. It says, I don't know the voltage of the voltage source. It's a voltage source, but I know the current, 5 amps. Okay, it's not a problem. So the value of the voltage source is 10 volts, let me say. Okay, this is my circuit. And let me make red. Okay, this is, okay. What's a node? Connection point of components. A node, another node, another node, another node. Okay? How many nodes? 4. Branch. One component until nodes. This is a node, sorry, branch. This is a branch, another branch, another branch, another branch. Yes. Ground. One of the nodes is selected as a reference. That's called the ground. Okay. Which node should be the ground? Yes, there is not any restriction. This can be a node, this can be a node, this can be a node, or this node can be a ground. All of them can be a ground. But negative side of the voltage source, okay, negative side of the voltage source is preferred. Okay, it will be easy to analyze analysis of the circuit will be easy if you select the negative side of voltage source. Yes. In this circuit, this current comes from 5 ohm and 2 ohms, and it goes like that. It goes on the 3 ohm resistor. Okay. What's node voltage? If you say this is E1, E2, E3, E4. To define a node voltage, you need ground. That's very important. If you don't define the ground, you cannot define some node voltage. So let me define E4 as ground. So the node voltage of this point is E1. It means E1 minus E4, but I have defined ground here, so it's 0. Okay, E1 minus 0 with E1. Okay. Yes, in this example, E1 is 10 minus 0 is 0. Good. Branch voltage. Branch voltage is a voltage of a component. Question: what's the branch voltage of 5 ohm? Branch voltage of 5 ohm. Positive side minus negative side. Okay, you can define any side as positive. For example, if you say the current is, if you define the current in that direction, you will say E1 minus E2. Okay. If you define the current in this direction, okay, then you will say branch voltage of 3 ohm is, help me please, branch voltage of this.
E2 minus
Positive side
E3
minus,
E4.
no, if you say E3 minus E4, you define the current downwards, but I have defined upwards.
E3 minus 0.
And E4 is the ground, so it will be minus E3, okay, minus E3.
Ama hocam o zaman çelişmiş olmuyor.
Okay. Branch current. I assume the branch current of 3 ohm in that direction. Let me say IZ. What's IZ?
Minus
You will say difference of node voltages E4 minus E3 divided by 3 ohm. E4 is 0, so minus E3 divided by 3 ohm. Okay. Okay. What does KVL say? KVL says define voltages of components. Okay. V1, V2. This is defined Vs. Let me say Vi and V3. Okay. And then you can write there is a voltage increase plus V source. There is a voltage drop here. Okay. V1 minus V1. Continue like that. There is a voltage drop again. Minus V2 is equal to, I have returned the same point, 0. Okay. The second loop, start from here and go like that. Okay. There is a voltage increase. If you switch from minus to plus, there is a voltage increase. Plus V2. There is a voltage drop here. Minus Vi. Continue. There is a voltage drop. Is 0. Okay. So look at these circuits. Assume that in this circuit, you know, this is 10 volts. This is 15 volts, and you don't know the VI. Okay, you know the current of the source, current source. You can analyze the circuit. Okay, you can analyze the circuit, but you don't know the voltage of the current source. How can you find? You will find the voltages of other components, resistors, and then apply a KVL.
Hocam fark olduğunu nasıl hesaplayacağız? Onu vermeyecek misin?
Assume I have given this circuit.
Bir sözle hesaplayamayız.
Yes, I have to give this voltage and this current to calculate the voltages of other components. Assume you have calculated, I have given to you, okay? And then, what is the voltage of this source? You will apply a KVL here. Apply a KVL like that. Help me. There is a voltage increase. Plus 10. Minus VI. Minus 15 is 0. So VI is 5 volts. Okay? Because there is no relationship between the voltage and current of a current source. You have to apply a KVL to find the voltage of a current source. Similarly, how can you find the current of this voltage source? Assume that you have calculated. This is 2 amps. Sorry, this should be minus. Okay. How can you find the current of this source? Assume you have calculated the current of this resistor, 2 amp. You have calculated this 1 amp. Sorry, you don't need to calculate this current. Okay, if you calculate that the current of this resistor is 2, what is the current of this source? You will apply KVL on this node.
Minus bir söz.
This current is equal to this current. Let me say this is IK. Okay. On this node, apply a KVL. This is KVL, sorry. I will apply a KCL. This current is coming. IK is downwards. What is the current in upwards? Minus IK. This is coming is equal to exiting current, 2 amp. So IK is minus 2 amp. Okay? Current division rule. If you have some parallel resistors, you can apply current division rule. You have some current source. Actually, you don't have some current source. Okay, you have some components, some circuitry here. It may be a current source, it may be another circuitry. Okay, if you know this current, let me say I. If you know the values of the resistors, you can easily calculate the currents. Okay, I1 is total current times the other resistor divided by the summation, and I2 is total current R1 divided by R1 plus R2. Okay, inversely proportional. High resistor gets low current, low resistance gets high current. So okay, for example, if you have a circuit like that, 5, 15, we know that this is 11 amps, ohms. Okay, question, what's the voltage of that resistor? We know the total current coming from the source, 11. Okay, the current of this resistor, if you say I1 is equal to total current times the other resistance divided by the summation of the resistances, which is equal to 10 amps. Okay, so V is current times resistance. Current is 10, resistance is 5, so which is 50. And for example, question, what's the voltage of the source? Okay, voltage of current source. How can you find? you can find the voltage applying a KVL like that. Okay, if you say this is Vx, you will say minus Vx, so there is a voltage increase. I will say plus Vx. Continue, there is a plus to minus, it means voltage drop, minus V is equal to 0. And I have calculated V is 50. So what's the voltage of the source? 50 volts. And yes, voltage division. If you have some circuitry, okay, anything, and if you have two serial connected resistors, R1, R2, the voltages are V1 and V2. If you know the total voltage, if this is V, okay, the total voltage of two resistors, we can say V1 is equal to total voltage times the corresponding resistance divided by R1 plus R2, and V2 is total voltage R2, R1 plus R2. Okay, this is directly proportional. High resistance has high voltage. Okay, for example, if you have 10 volts and 5 ohms, 15 ohms. Okay. Question, what's Vx? Vx is total voltage, its resistance, summation of the resistances. Okay. 2.5 volts. I can say the most important part of this course is nodal analysis. What to do in nodal analysis? Select a ground, give names to nodes, okay, write KCL equations on only unknown nodes, okay, solve for node voltages. Okay, in this step 4 you will find the node voltages, then you will find the others. Find other values. Okay, how? Let me analyze a circuit. Let me say 10 volts, 5 ohm, 3 ohm, 10 ohm, 2 amps. Okay. Question, what's Ix? Okay. So Ix is the current of a resistor. Let me apply the node methods. Step 1, select the grounds. This is my circuit. I select this point. Why? Because it is the negative side of voltage source. Can I select other nodes? Yes. But if I select the node which is connected to the negative side of voltage source, my job will be easy. Analysis will be easy. Step 2, give names to nodes. This is my circuit, E1, E2, E3. And I can write E1 actually, but this is a known voltage, so I can write the voltage directly. Okay, let me write E1 is 10 volts. I know that. Why? There is a voltage source and negative side is 0. So the difference between 2 points, 2 terminals of the voltage source should be its value. 0 plus 10 is 10. So there are two unknowns. Okay. Then step 3. KCL equations. Okay. This is the circuit. Let's write the KCL equations. KCL equations on only unknown nodes. Unknown nodes are E2 and E3. Okay. Let's write the KCL on E2. This current, and this current. Entering currents is equal to exiting currents. What is the current on that resistor? Positive side E1. What's E1? 10 volts. Minus negative side E2 divided by resistance 5 ohm. Entering current is equal to summation of exiting current. What is the current from E2 to E3? Yes, this is IX actually. What's the current through right? Look, 2 amps. Plus, what is this current? E2 minus 0, so no need to write, divided by 3. Okay, this is the first equation. The second equation is for E3. Okay, let's write E3 together. It will be on this. Okay, this current is equal to that current. Entering current to E3 2 is equal to exiting current E3 minus 0, no need to write, divided by 10. Okay, so what's E3 here? You can find E3 easily. E3 is equal to, okay, if you write E3, no need to write E3, you can directly find E2 from here. Okay, then question, what's IX? The actual question is this. Step 5. Step 5, find the other values. The question is IX. What's IX? Yes. Can you help me? After finding the node voltages, what's IX? E1 minus E2 divided by 5. Okay, E1 is very obvious, 10. You can find E2 from this equation. Okay, then you can easily find this current. It will be in amps. Look, this is the KCL equation, but I have used voltages. How? Actually, let me give some names. This is IX, this is IY, this is IZ. I have written that this is IX is equal to IY plus IZ. IX is voltage divided by resistance. IY is already a current source. IZ is voltage divided by resistance. Okay. So in nodal analysis, you have to write the currents like that. Positive side node voltage, negative side node voltage divided by the resistance, if it's a resistor. What's a supernode? Supernode is a voltage source. Okay, a voltage source not connected to ground. Okay, if there is a voltage source in the circuit which is not connected to ground, you have a supernode. Look at this circuit. Okay, how to analyze that circuit? Using node methods. You will say, okay, this is Vx, let me say, this is Vy. You will say the voltages of the nodes E1, E2, E2, E3, that's it. And this is the ground. You have 3 unknowns. Okay, you can apply the node methods, you can find, no problem. But supernode says Instead of writing 3 equations and 3 unknowns, you can say, look, what's Vy? Vy is given. Is the difference between E2 and E3 positive side minus negative side. Okay? And actually E1 is known here. Okay? If you don't use super nodes, okay, nodal analysis, in this circuit there are 2 unknowns. Okay, 2 unknowns. In super nodes, E1 is already known. You say this is a super node. Here is a super node, and you will write one equation. This current plus that current is equal to these 2 currents. Okay, that's it. You will write only one equation. Let's write R1, R2, R3, R4. Supernode equation. Okay, what is the current into supernode on that resistor? Current E1 minus E2 divided by R1 plus, what is this current? 0 minus E2 divided by R2 is equal to this current, help me please, E3 divided by R3 plus this current, E3 divided by R4. Okay, only one equation, and the other equation comes from supernode equation. Supernode equation is this: Vy is the difference between 2 points, positive side minus negative side. That's it. Okay. Question: what is the power dissipated by 7 ohm? You can analyze this circuit using normal nodal analysis, no problem. But if you apply supernodes, your equations will be less. Okay, one equation is eliminated. If you apply normal nodal analysis, E1 is obvious, 3 volts. You will have 2 unknowns, E2 and E3. Okay, normal nodal analysis. Equation of E2 is, this current is 3 minus E2 divided by 5 resistance. Okay. Then this current upwards, 0 minus E2 divided by 4 is equal to, this is IZ. Okay. Then you will need another equation at E3. This current is IZ, because IZ is entering, the same value should be IZ is entering, the same value should be exiting, is equal to this current E3 minus 0 divided by 7 plus E3 minus 0 divided by 8. Okay, but there are 3 unknowns. You need one more equation. Okay, look, E2, E3 and IZ. You have 3 equations. So the other equation is this. That's called the supernode equation. Okay. Vy. What's Vy? Sorry, Vy is given here. 6 volts. 6 volt is the difference between E2 and E3. Okay. 6 volts is equal to E3 minus E2. Look, minus plus. E3 is 6 volts higher than E2. So you have 3 equations if you use nodal analysis. But if you use supernodes, what happens? Let's check. if supernode applied, you will write only one equation. Entering current to supernode. Okay, this is supernode. Okay, supernode is the combination of two nodes including one voltage source. Entering current is this 3 E1 minus E2 divided by 5 plus this current 0 minus E2 divided by 4 is equal to exiting currents. This E3 divided by 7 plus E3 divided by 8. Okay, one equation. And we know that the supernode equation 6 volt is E3 minus E2. Okay. Now I have two equations and two unknowns. If you don't use supernode, you will have one more equation, one more unknown. It's easy to analyze. After finding E3, what's the power dissipated by 7 ohm? Power dissipated by 7 ohm is voltage squared divided by resistance. What's the voltage of 7 ohm? E3 minus 0 squared divided by 7. Okay. After finding E3, the power of 7 ohm is very easy to calculate. The next important topic is the mesh analysis. Yes, I want to solve if I can. What's mesh? Inner loops. Okay. Look at the circuit. Vx, Vy, Ry, R1, R2, R3. How to apply mesh equation? Define mesh currents I1, I2. There are two meshes. Then write KVL equations. It's a good application to define a node, of course. Apply the KVL equations. Okay, minus Vx plus. There is a voltage increase, so I will write plus Vx. Then I1 is the current in this mesh. Okay, plus this voltage. Sorry, minus that voltage. There is a voltage drop. Minus R1 times I1. Okay, because this current is I1. What is this current? I2. What is that current? What is this current? I1 is in the same direction, I2 is in the opposite direction. So this is I1 minus I2. Okay. So what is the voltage? What is the voltage drop on this resistor? Minus R2, I1 minus I2 is 0. Okay. The loop equation or KVL equation for the second loop. Start from the left button here. This current, okay, this current causes a voltage drop if you come from the upper side. But if you go from low to up, okay, down to up, there will be a voltage increase because I have defined this is positive side, this is negative side of that resistance. Can you understand? So there is a voltage increase because low side is the negative side of that voltage. If you switch from low negative to positive side, there will be a voltage increase. So I will write plus R2 I1 minus I2. There is a voltage increase, okay, because I have defined the current is in that direction. Current flows from high to low voltage on a resistor always. Okay. Do I write plus or minus here? Question. Do I write plus or minus here? Can you help me? Is this a voltage? Yes. What is the positive side of that voltage? What is the positive side of this voltage? No. I1 minus I2 is the current downwards. Okay? That current flows downwards. So upper side is positive, lower side is negative. So if I am drawing a KVL loop like that, okay, I am switching from minus to plus. It means there is a voltage increase. Okay, this is high voltage. This side is high. This is low. Okay, so voltage is increasing. I have to say plus. Then I2 R3. This is positive side, this is negative side because of the direction of current. There is a voltage drop. Minus R3 I3. There is a switch from plus to minus. Is it increasing or decreasing voltage? Is the voltage increasing or decreasing? Increasing. I am switching from plus to minus. Decreasing. Minus Vy is 0. Okay. I have two unknowns, I1 and I2. Okay, in mesh equation. Okay. No, I2. Sorry, I2. There are two mesh currents, I1 and I2. So solve for I1 and I2. And after finding the mesh currents, you can find everything. For example, question: what is the power generated by Vy? Power generated at Vy. Question: what is the current of that source? Vy. What's the current? Yes, I2. So if you write Vy times I2, what's this? Is it power generated by that source or power dissipated by that source? If the current enters from the positive, multiplication is power dissipated. So this is power dissipated. Question asks power generated. So I should say minus. Okay. This much of watts. Okay, let's analyze the circuit. Power generated by, let me say, 20 volt source. Okay. So what I should do is this. If this is current I should do 20 times current, but that current is entering from positive, so I should say a minus. Okay, there should be a minus at the beginning. Okay, 20I is the. So let's analyze this circuit using the mesh analysis. There are two meshes. Let me say I1 and I2. I will write two KVL equations. Okay. KVL equation for mesh 1. Yes. Maybe, of course, but the direction of current is important. The direction of the current is clockwise here, so you will use this direction. Okay. So current is entering from positive. It means this side will be positive. Okay. Similarly, this side will be positive. So from minus to plus, there is a voltage increase, plus 10. Then from plus to minus, there is a voltage drop, minus 5 times I1. Okay. And now, what's the current of this branch? I1 is supporting, I2 is opposing. Okay, I2 is from down to up. So the current downwards is I1 minus I2. What is the current upwards? on that branch? Yes, I2 minus I1. So I use downwards. It means this is plus, this is minus. I will say minus 10 I1 minus I2 is 0. Let's write the second mesh equation. Okay. From minus to plus, it means there is a voltage increase. I will say plus. Resistance times the current. Okay. I'm writing this. Okay. Then from plus to minus, current, sorry, what's the voltage? There is a minus 15 current. Then plus to minus, again there is a voltage drop. Look, it's a voltage source, but because of my direction, if I follow the opposite direction, there will be a voltage increase. But I go in clockwise, switching is from plus to minus. There is a voltage drop. And I have returned the same point, summation is 0. Two unknowns, two equations can be solved. After finding I2, what is this I? In terms of I1 and I2, it's equal to I2. So minus 20 I2 is the power generated by that voltage source. Okay. Then, what's a super mesh? A super mesh is a current source between two meshes. Okay. If you analyze these circuits with mesh analysis, you will have two equations, I1, I2, two mesh currents, two equations, two unknowns, and you can solve. Super mesh says instead of writing two different equations, write only one equation. Write this equation. Look, start from here and follow this path. Okay? That's a loop. You can write a KVL, no problem. Let's write. There is a voltage increase. Plus 10. Continue. There is a voltage drop. 5 I1. Continue. Minus 20 I2. There is a voltage drop. Continue is 0. One equation. And you can write this equation too. What is this? I1. What is this? I2. So what is this? 10. It's given in the circuit. So write a KCL equation here. I1 plus 10 is I2. So you have two equations now. Solve easily. That's it. Super mesh. What's super mesh? Is composed of two nodes connected with a voltage source. Okay, is the combination of two nodes. Two nodes are together is a super node. So between these two nodes, if there is a voltage source, they are super nodes. Super mesh combination of two meshes. Okay. which have the same current source which they include the same current source. Okay, like this. There is a mesh here, there is another mesh here, here there is a current source. Okay, so you will write one mesh equation like that. The last topic, op-amps. Okay, op-amp is the operational amplifier, as for the plural. Okay, symbol, a triangle. Inputs, there are two inputs which are not connected to ground. Okay, which don't use, these input don't use the ground as reference. Okay, the difference of these two input cable accepted as the input. Okay, the difference is important. For example, it can be 1 million plus 1. This can be 1 million minus 1 volts. 1 million volts. So what's V in? 2 volts. That's it. Okay, the difference is important. V out. V out uses the ground as the reference. So V out is actually this. This is plus side. This is minus side. That's very important. And the input voltage is amplified. Where does the high voltage comes from? Where does the high voltage come from? It comes from the voltage sources. Positive voltage source, negative voltage source. Okay? So if you connect plus 15 here, this should be minus 15. If you connect 0 here and 30 volts here, it assumes 15 volt is 0. Okay? The midpoint is ground. It uses the midpoint as the ground. What can you do with operational amplifiers? You can compare two signals. V1, V2, V out, plus V source, minus V source. This compares two voltages. V out is equal to plus V source if V1 is higher than V2. Why? Because this difference is positive and it tries to amplify that difference with a very high ratio, 1 million for example. Okay, but sorry, it should be 1 million times amplified, but it's impossible because this voltage source is lower than that value, so it saturates at that value, and the output will be positive V source, and V out is equal to minus V source if V2 is higher than V1. Because if V1 is higher than V2, it means V in is positive, V in is negative. Okay? And you can do inverting amplifiers. You can amplify a signal, sound signal, voice signal, video signal, any signal. How? You will use some extra resistors. Let me call RF because it's used to feedback. Or let me connect directly to the ground. If you do this connection, look, V plus, what's V plus? This is V source. What's V plus here? 0 volts. What's V minus?
V source.
It's connected to here. No, not V source. V out. R1. We know that I haven't explained this. The current of this is I plus, this is I minus. Okay, I plus, that's very important. That's why I am writing with very bigger fonts. I plus is equal to I minus, which is always 0. No input current to the op-amp. You apply a voltage but no current. So write a KCL equation here. This current is equal to that current because there is no current here. Okay? And we know that, that's very important, if there is a negative feedback, okay, NF means negative feedback, let me write, negative feedback, V plus input is equal to V minus input. Voltages of input terminals should be equal. Okay, op-amps causes that result. It's the property of op-amp. I have explained in details, but you don't have to know the explanation. If there is a negative feedback means a connection from output to the negative input. This is the negative input. If there is a connection, yes, there is a connection here. V plus is equal to V minus. So this is 0 volt because of the ground, and this is 0 volt because of the negative feedback, 0 volts. If you write a KCL equation, this current, what's the voltage of this point? V source. V source minus 0 volt divided by resistance is equal to 0 minus this voltage, V out, divided by RF, resistance. Okay? So from here, V out is minus RF divided by R1 times V source. Sorry, V source. So changing the resistances, you can get the amplification. But the value is always inverted. For example, if V source is 5 sine 100t millivolts, then V out is minus RF is a resistance. RF and R1 cannot be negative. R1 times 5 sine 100t millivolts. Okay. So if you use the, for example, same resistors, the output will be the negative of the input, 1 divided by 1. Okay. If you use 5 times higher resistor, feedback resistor, the output voltage will be 5 times higher. But because of that minus, the output will be in the negative direction, negative polarity. Let's say polarity. For example, look at this signal. Okay. This is V in, V source. Okay. This is V out. The same signal, it's inverted. Okay, inverted by the x-axis, and it's amplified. If you use a speaker, for example, here, okay, if you connect a speaker, these two, you will hear the same sound, same speech. Okay, and this will be louder. This will be silent. Okay. And non-inverting amplifiers, it can be configured like that. If the input, if the source voltage is connected to the positive input like that, instead of the negative side, if you connect the positive side, this will be the non-inverting, and this point is V source. There is a negative feedback, so this voltage is V source 2. We know that if there is a negative feedback, V plus should be equal to V minus, and if KCL is applied on this point, V out will be 1 plus RF divided by R1 times V source. So as you see, this portion is always positive, so the gain is always positive, and it's always higher than 1. And a similar circuit like that, V source, V out. Again, there is a negative feedback. Actually, there can be some resistor here or not. It's not problem. This is V source and this point is V source, so V out is equal to V source. V out is equal to V source. This configuration is called buffer amplifier. And what's the advantage of this amplifier? There can be any current, but this current is 0. If you have a source that you can read some voltage but you cannot get some current, you can use a buffer amplifier to read the voltage which is not affected by the output current.